Hello everybody, welcome to Python for Everybody. We are doing some code walkthroughs. If you want to follow along with the code, you can download the source code from Python for Everybody, the Python for Everybody website. Okay? So the code we're playing with today is twfriends.py, and this is a step beyond the simple TW spider. It is a restartable spider, but we're going to data model things a little bit differently. We're going to have two tables, and we're going to have a many-to-many relationship, except that it's sort of a many-to-many relationship between the same table, which is okay. Friends is Twitter friends are a directional relationship, and so we start out here in twfriends.py. Remember that the file hidden.py, I'll show it to you, but I'm not going to open it because I've got my keys and secrets in it. So this hidden.py file, you got to edit that, and you got to go to apps.twitter.com and get your keys and put them in there. Otherwise, these things won't work. But if you have Twitter and you set your API keys up and you put them in hidden.py, then all these things will work. It's kind of fun, actually, and impressive. Not hard to do, actually. So the Twitter URL, that's my library that reads hidden.py and augments the URL and does all the OAuth stuff. JSON and SSL because because Python doesn't accept any certificates, even if they're good certificates, so we kind of crush that. Here's our friends list that we're going to hit. We're going to make a database, friends.sqlite. Now here we're doing create table if not exists. So what this really is saying is I want this to be a restartable process, and I don't want to lose the data. We're starting out, we do not have SQLite. Any SQLite files, and so this is going to create the database and create these tables, but the second time we run it, we're not going to recreate the tables. We're going to be able to restart this because we're going to run out of rate limit before we finish this. But so we just have to wait however long the rate limit takes to reset, and we'll watch the rate limit go down. And so we're going to have a people table, and we're going to have a primary key and the name. The name is going to be unique, and whether or not we've retrieved it. And that's kind of from a previous one. But then there's the who follows who, the from ID to to ID. And so this is a direction, and we're going to put a uniqueness constraint in, just like we do in many-to-manys, that basically says the combination of from ID and to ID has got to be unique. We don't allow ourselves to put duplicates of the combination. So from ID can be 1 in many records, and to ID can be 1 in many records, but 1 is only allowed once. And this is the CRUD we have to do to convince Python to accept the Twitter certificate. And so this is similar to some of the other stuff that we've done. We're going to enter a Twitter account or quit. And if we hit enter by itself, then we will actually go and retrieve a record that was not yet retrieved. And now we're actually pulling out two values, ID and name. And so we will grab fetch1 is going to give us a two tuple basically. And we're going to store that in ID and account. Of course, that's like this is coming back with a two tuple, first of which is the ID from the database. Limit 1 means we're only going to get one of these or 0 of these. If there are 0 of these, that means there are no unretrieved Twitter accounts. Retrieved equals 0. Well, you'll see in a second that all the new accounts we put in are the ones for which we haven't retrieved. And again, given that our rate limit, we want to know which ones we've retrieved. Okay? And so what we're going to do next is we're going to check to see if the person that we just checked, which means the length of the account is greater, that we just were entered, we're going to check to see if they're already there. Okay? And we're going to select ID from people where name equals, so that's the one we just entered. And we're going to fetch one and grab the first thing because we only got one thing in the select statement here. And if this person that we just asked to see is not in the table, that means this is going to fail. We're going to do an insert or ignore. This or ignore is kind of redundant because we just checked to see if it was there, but we'll put that in just to be safe. And we're going to put the name in as the new account that we're looking at, and we're indicating that retrieved is 0, so that we will know that we haven't retrieved it yet. You'll see that we'll update that in a second. We commit it so that later selects will see this. So you gotta do the commit. This later select wouldn't see the one we just inserted. and we're going to ask how many rows were affected, and if it's not equal to 1, then we're going to complain about we inserted it, and we are going to do this thing. We're going to ask, hey, remember there was an ID up there? Right here, ID integer primary key, and we did not insert this here, but we want to know what that ID is. And every time I was showing you that in lectures, I was saying it's really easy in Python to do this. And that's what we're saying. Is this cursor did the insert, but one of the things happens is after the insert, we're going to grab the last row ID, which is the primary key that was assigned by SQL. Okay? And so that means that one way or another, coming through this code here in line 45, one way or another, we're either going to know the ID of the user that was there before, or we just inserted one, and so we're going to know the primary key of the current user. And you'll see why we need that. So ID is the primary key of the current user that we entered right here. Okay? And now what we're going to do is do the Twitter URL augment with the OAuth and all the keys and the secrets and hidden.py. Instead, we're going to go through, let's count 1,000. Let's go count, what the heck, let's go 200, up to 200 friends. Save. No, let's do 100. We'll keep it that way. And then we're going to retrieve it, and we're retrieving the account. We're not going to print the nasty URL out. We could. Then we're going to open the URL with a connection, and then we're going to read that, and we're going to get the UTF-8 data from this, and then we're going to decode that, and we're going to have the Unicode data. So the data string is an internal Python string with all that data representing all the wonderful characters. And of course, we're going to ask URL open to give us back the headers as a dictionary using this call, and we can see what how many we have left for the remaining, right? What's the remaining rate limit that we have, okay? And so then what we're going to do is parse the data with JSON load S. If, oh wait, I need a continue in here. Continue, okay, save. If we are going to parse this data, we'll print it out, right? So that means that this died, which means it's not syntactically correct JSON, basically. And who knows if we're ever going to see that, but at least when it blows up, it'll print this data out. We'll have to catch it, and then it'll continue. Actually, I'll make this a break, because if that's blowing up that bad, we should quit. Now, I don't yet know what happens when this rate limit says you can't have it. And so, but I do know that I expect when it's successful that there will be a key of users in this outer dictionary that we're going to get. And if this outer dictionary that if users is not in the parsed dictionary, then I'm going to dump out this data so that at least I can debug what happens when I've got some broken JSON. So the difference between this code is going to fail when the JSON is syntactically bad, meaning a curly brace isn't right or whatever. This code will trigger when I get good JSON, but I don't have a user's key in it. Okay? So then, once we've retrieved it, we're pretty happy with it. We're going to update for our account that we are retrieving. We're going to set this is one of our retrieved accounts. Okay? And then what we're going to do is write a loop that goes through all the friends of this particular user that we're asking and gets their screen name, prints it out, and then we're going to check to see if this one is already in our people database, because this is a spider. We're grabbing accounts, and so we'll do a friend ID and do a fetch one, grab the sub-zero thing, and if that works, if this person's not in there, this fetch one is going to blow up, which means we're going to drop down to the accept code. But if it does work, we have friend ID is the, that they're there and they're already in our database, right? They just weren't retrieved. Okay, and so now if the friend ID wasn't there, we're going to do an insert into setting retrieve to 0, and then we're going to commit, right? Now, remember, row count is how many rows were affected by this last transaction, cur.row count, and we're going to die if that insert doesn't work. This is unlikely, unless somehow we've ran out of disk drive or something. And we're going to grab the friend ID as the key, the last row that was inserted. We're only going to insert one row, so it's basically the primary key of the row that we just inserted. So if you look at this code right here, it comes out the bottom one way or another with friend ID successful, right? Friend ID is either they're already in our database or they're not. And if we insert them, then we have it. And so now, this count new and count old is just so I can print out a nice printout. Now we are going to insert into the friend table, which is called the follows table in this case, from ID and to ID. Those are the two outward pointing foreign keys. And we have the ID of the account that we are retrieving the friends of, and then this particular friend. And so we're inserting the connection from this person to that person. And then we commit it. We want to commit these again so that later selects, when the loop goes back up, later selects get all of that data that's going on. Okay, so we do want to commit from time to time, and then we close the cursor at the very end. Okay, so let's run this and see what happens. Okay, so Python twfriends.py. Oh, of course, I am a refugee from Python 2, so I always forget to type Python 3. Okay, so we're going to start. If we take a look right now, I'm going to start another tab over here, and ls-l star SQLite. Now that SQLite file is there, right? And it's actually made the tables. If you go up here, it ran all this stuff. Create the tables, yada yada, and we're sitting right here at this line. As a matter of fact, I think without causing too much trouble, I can open that database and get into this database right here, and there is no data in the follows table, and there is no data in the people table. It's completely empty. Okay, so we're waiting for the first one, and I'll go with mine, Dr. Chuck. So it's retrieving the 100 friends, and they all were brand new. They're all inserted, right? And so now if I hit refresh, we will see that Dr. Chuck is retrieved. Who follows? So these are all the people I follow. So one follows two. So if we look at here, we see that Dr. Chuck follows Stephanie Teasley. Because we grabbed the followers of Dr. Chuck, you know, we're going to have a record in all of the follows for all the ones that I did, right? So these are all the people I followed, and we put them in. Okay? So we can go back, and we can, let's see, grab somebody. Let's go grab Stephanie Teasley. And let's pull out her friends. So we grabbed 100 of her folks. I got 14 left. That's my X rate limit. So I did Stephanie Teasley. So let's go back here. So you'll notice there's 101. There's probably going to be, 182. That's interesting. So we've retrieved Dr. Chuck and Stephanie Teasley. And let's go take a look in the friends table, the follows table. Okay. So we have all of the people I follow. Now all the people Stephanie follows. Okay. So there we go. So let's go ahead and do somebody else. Let's see. I think we both follow Tim McKay. Where's Tim McKay? Yeah, let's follow Tim McKay. Let's see who Tim follows. See if we can get like an overlap. Oh, we revisited some. Let's see if we can see this in the follows. Let's see people. So we've got Dr. Chuck retrieved and Tim McKay's somewhere down here. Yeah, it might take us a while before we get any really good overlaps. Let's see. Let's do a database call. Let's do a database SQL. Select count Okay, so let's just run this some more. It's clearly working. Now, one thing I can do here is I can hit enter, and it will just pick one randomly. So it grabbed live edu TV, and now I can, and let's see how many I got left. We got 12 left, and now I can hit enter again, and it picks another one. That was the next one. I was kind of picking them in order. Is it picking them in order? Let's go to people. Yeah, it's picking these So it's going to, we can see that it's going to just do the first unretrieved person, who's Nancy. Let's let it retrieve Nancy. So it grabbed Nancy, new. So we're finding some. And this table's getting really big. And so if we look at the people table, we now have 455 people. And we have 467 following records. And so there we go. Oops. Hit enter, it does another one. And away we go. So you get the idea. I can type quit to finish. And just to give you a little interesting bit of code to show you how to do selects, I'm going to do this TW join. Now you'll notice that we're not talking. Oh, let's show you one thing. ls-sl friends star SQLite. So this database has it, so I can restart this process and run it again, and the database is still there. And so we just grab swear trek, and so we can keep doing this, and so this data, it keeps extending, and so this is a restartable process. I can run it and then tell it to grab the next unretrieved one, and so away we go, right? And so that's part of it. So I can, if I run out of my, I've got 8 left. Oh, how many do I have left really? Let's keep going. How many do I got left? I got 5 left. Okay, wait. Oh, I guess we'll just run it out. So I got 4 left. You know what I should do is I can't change the code. Yes, I can't change the code. I can stop the code and I can quit the code. So what I'm going to do is I'm going to change this code a little bit really quick. And I'm going to print the headers of rate limiting at the beginning and at the end. So now I can run it again. I changed the code. Hopefully I didn't make a Python error. Tell it to go get another one and a Navarro. And so I got 3 left. Oops. We'll see what happens when I run out of rate limit. Run out of rate limit. So we have 1 left. Hit enter. Hit Control K. Opensource.org. So we have 0 left. That worked. Now let's see what happens. I don't know what happens next. Oh, we blew up. Too many requests. Oh, we got an HTTP error 429. So that means that, going for Mark Cuban, that was in line 48. So the right thing to do would be in line 48. We should really put this in a try except block. Try except block, because it gives us an error. Print, oh fiddlesticks. How do I print the exception message? I always am forgetting. Print failed to retrieve. Okay, so we'll put that in. Now if I run it, oh, and then I have to put a break here because that's not good. Break. Failed to retrieve. Now I got to figure out. Oh, I never know how to print out the error message. Yeah. So I have to. I never see. That's the weird thing about stuff, is that I don't ever remember enough. I don't remember the syntax, what I say here, to print the error message out. So I'm going to go to Google, and I'm going to say print out the exception message in Python. Print out the exception message in Python. Oh, Python 3. Hello. Okay, so let's go find it here in the documentation. Except. Is this it? Is this what I say? just want to print out the message. Ah, that's it. Accept. Let's try this. So this is part of Python programming, is like, for me at least, because I'm just not like a genius expert at this stuff. Ha! This is one thing I like about Python, is you can guess stuff, and sometimes you guess right. So there we go. We got the error, we got the nice little error message, and we see error 429, too many requests. So that cleans that up nicely. So we have run out of requests, and on that, it is a good time to say thanks for listening, and I hope that you found this valuable.